Okay, here are some example problems, like the homework assignments. So, one group of problems gives you a point in Cartesian coordinates, and they ask for the trigonometric functions associated with the angle between the positive x-axis and the line that's drawn from the origin to that point. So you can see that's what we have. This is the angle. Here's the point. And all you have to do is use the definition for the 6 trigonometric functions based on the x, y, and r values. So r being the distance from the origin to this point. So the distance is r is always positive. So in this case, r is equal to the square root of -3 squared plus 5 squared, which is going to be equal to the square root of 34. So you get 25 plus 9 is 34. So that's r, and x is -3, and y is 5. So we have that the sine of theta is, it's going to be y over r. Cosine of theta is, I said r and I wrote x, sorry, y over r. Cosine of theta is x over r. Tangent of theta is y over x, except x cannot be equal to 0. Then you have, let's just go ahead and do these three. So y is 5, r is the square root of 34. So we multiply and divide by the square root of 34. Okay, so that's the sine of theta. Then we have x, which is -3, divided by the square root of 34. Multiply and divide by the square root of 34. And then y over x, y is 5, x is -3, so you get -5/3. Okay. Now, just pull these over a little bit. Let me just group these together so I can move them. There. I don't know why they didn't group together like that. Okay, now it works. Okay. So then we have the sine, so we have the cosecant of theta. That's just r over y, except y cannot equal 0. So that, what we do there is we just take this version with before the simplification. So you get square root of 34 over 5. The secant of theta is r over x. So again, we'll take this, so it's going to be negative the square root of 34 over 3. And then finally the cotangent of theta is x divided by y. So it's a reciprocal of that, so it's -3/5. Group all those together too. Okay, so that's how it works. Notice that the signs of the sine and cosecant are the same. Cosine and the secant, the tangent and the cotangent. Positive, negative, lost, negative. Okay, the next group of problems, instead of plotting this, you just give it a point. So to make the next two problems like the first problem, you just plot them, and then you can do the same thing. And you really don't even need to plot them, but it's kind of nice to know what quadrant you're in. This first problem was in the second quadrant. This one is in the third quadrant, so we don't have to be that accurate. -4, -3, so it's about there. and we just want approximately the right direction. And so again, we're looking for the angle. This is the angle between the positive x-axis and the line that represents the line that goes through the origin through this point. And they ask us to determine the exact values of the six trigonometric functions. Now the reason they say exact is because you could figure out what theta is and then use your calculator to get the other trig functions, but we're just going to use these definitions. So sine of theta is equal to y divided by r. So we have to calculate r. R is equal to the square root of -4 squared plus -3 squared, which is 5. So this is one of these 3, 4, 5 triangles. 16 plus 9, 25. The square root of 25 is 5. And that makes it so you don't have to deal with square roots, which is nice. Okay, so r is 5, x is -4, y is equal to -3. So here we get -3/5. The cosine of theta is x divided by r. X is -4, so you get -4/5. You have the tangent of theta, that's y divided by x. So that's -3 divided by -4, which is 3/4. And then the corresponding reciprocal functions, you just take the reciprocal. So that's -5/3. This one is the secant of theta, that's -5/4. And the cotangent of theta is 4/3. So you got 2 of those problems. But I would ask you to draw the draw a coordinate axis and do the approximate thing. Okay, the next one, it says state in which quadrant the angle lies. And what you can do here is you can, you do this whole thing, all students take calculus. So what that says is that they're all positive in the first quadrant. And let's do sine, cosine, tangent, sine, cosine, tangent. So in the second quadrant, the sine's positive and the other two are negative, sine, cosine, tangent. In the third quadrant, the tangent's positive, so the sine's negative, the cosine's negative, the tangent's positive. And in the fourth quadrant, the cosine is positive, but the sine and the tangent are negative. So if we look at this, the cosine of theta is greater than 0. So we can say the cosine of theta is greater than 0 in the first and fourth quadrants, and the tangent of theta is less than 0, that's this last thing, is less than 0 or negative in the second and fourth quadrants. So the only place both of those things are true is in the fourth quadrant. So that's one way of kind of doing it. There's another way, but I can't. I guess you could make up a table which says the quadrant and then just kind of make up a table, 4x3 table, 3x4 table, 4x3 table, 4 rows, and then you'd have sine, cosine, tangent, and then you could go in the first quadrant and they're all positive. All students take calculus, so they're all positive in the first quadrant. The sine is positive in the second quadrant. The tangent is positive in the third quadrant. The cosine is positive in the fourth quadrant. And then you can go back and you can just put negatives where everything else is. And notice there are 12 total, 12 possibilities, 4 quadrants, 3 trig functions. 1, 2, 3, 4, 5, 6 positives, and 1, 2, 3, 4, 5, 6 negatives. Makes sense. Symmetric. Things are symmetric. Okay, here's another one. The only difference, so let's use this, but another thing you can say is that the sine and the cosecant, the secant and the cosine and the cotangent and the tangent have the same sign. So the secant, which is here, is greater than 0 in the first and fourth quadrants. And the cosecant, which is the same as the sine, is less than 0 in the third and fourth quadrants. So, same answer as the previous one, or for different reasons. So the answer is Q4. These both are true in the fourth quadrant. Okay, now here we got the same kind of thing, except once we figure out what quadrant we're in, then we can figure out all the other trig function values. So this says the sine of theta is less than 0 because that's negative, and the tangent of theta is less than 0. So again, let's take that one chart and move it down here so we can use it to figure out what quadrant. So you first figure out what quadrant, Q question mark. So the sine of theta is less than 0. So we go out here to sine. It's the third quadrant and the fourth quadrant. The tangent is less than 0 in the second quadrant and fourth quadrant. Okay, got the same answer again. Fourth quadrant. Okay, so this is the one, fourth quadrant. Now, so how do we figure out the rest of it? Well, you can create a right triangle which has all positive sides, and let's say this is theta, and the sine SOHCAHTOA what is it? I don't remember SOHCAHTOA, I just remember what it is. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, because that's SOHCAHTOA. So we're given the sine. So what it says is the sine of theta, which is opposite over hypotenuse. In our case, it's negative 4/7. So what we do is we ignore the negative sign right now. So the opposite is 4, the hypotenuse is 7, and then you use the Pythagorean theorem. So let's call this x, the unknown side. X squared plus 4 squared equals 7 squared. So that's x squared equals 49 minus 16, which is 33. So x equals the square root of 33. Okay, so this is equal to the square root of 33. Now, what we can do is we can do all the trig functions and then come back and figure out what the sines are. So let's say, so again, the sine of theta equals y over r. R is the hypotenuse. So let's write what they are, what these things are. Well, actually, there's two ways of doing this. Let's actually do it this way. So now that we've got the lengths of the sides, we can draw this in space. So here's our coordinate system, and we figured out here it's in the fourth quadrant. So let's draw a side in the fourth quadrant, and this is the x coordinate and this is the y coordinate, but you can see the y coordinate is negative. So this point here is going to be x, which is positive, and x is the square root of 33. And y is y is negative, and the vertical side of this triangle is 4, so it's going to be negative 4. Okay. And once you define that point, then the rest of it's just like before. So the other way of doing it would be to remember that in the fourth quadrant that the sine is negative, tangent's negative, cosine is positive. So that would be another way to think about it. But so let's write all this stuff in here. Now that I've got this, the sine, this negative sign, where did that come from? Which one is it assigned to? Well, it's due to this negative y coordinate. So we got x equals the square root of 33, we've got y equals negative 4, and we've got r equal to 7. So this is negative 4/7. Cosine of theta is x divided by r, which is going to be the square root of 33 over 7, so that's in good shape. The tangent of theta is y divided by x, so that's negative 4 divided by the square root of 33. This is one we have to multiply and divide by the square root of 33. And you see what I'm doing, when I multiply by the square root of 33 in the denominator, I get the square root of 33 times the square root of 33, and I get 33. So that's kind of the procedure I'm going through here. And I'll have to do that. Anytime you've got one of the dimensions as a square root, you're going to have two of the trig functions where you're going to have three of the trig functions where, well, three of that you probably have to do rationalization. Okay, so the opposite of this, the reciprocal of the sine is the cosecant. So that's just negative 7/4. The secant of theta is 7 divided by the square root of 33, or 7 times the square root of 33 over 33. And the cotangent of theta, we can just take this unsimplified version and just take the reciprocal. So you get the square root of 33 over 4. So actually there's only two that we had to do. We had to do this multiply and divide by the square root of 33. Okay, the next one, it gives you a line and kind of line which defines one side of the one of the sides of the angle, and it tells you what quadrants it's in. So let's draw this line and see what it looks like. So we've got that, and we've got this. So there's the x and y axis. Now this line goes through the origin. So we'll start at the origin because there's no plus or minus b here. So we go through the origin, and it has a slope of 1/3. So that means that I've got a rise of 1 and a run of 3. So I got 1, 2, 3, 1. So this point is going to be 1, 3, 1. The x coordinate is 3. And once you have a single point out here, now but the tricky part is that's in the first quadrant. So you have to remember that this thing is symmetric. It just goes that way. So another that one's actually irrelevant. What you have here is you have that point, which is going to be -3, -1. So what we have is x equals -3, y equals -1, and then we have to figure out r. R is equal to the square root of -3 squared plus -1 squared, which is the square root of 10. So that's r. R equals the square root of 10. So now, back to our definitions. And the angle, well, before we do that, what does the angle look like? Well, it starts at the positive x-axis, it rotates around to that point. It's in the third quadrant, Q3. So we have that the sine of theta is y divided by r. So y is -1, r is the square root of 10. So plus multiply and divide by the square root of 10. So we get negative the square root of 10 over 10. The cosine of theta is x divided by r. X is -3. R is the square root of 10. So you get -3 square root of 10 over 10. Then you have the tangent of theta is y divided by x. Y is -3. X is -1. Never leave double negatives, so you just get 3. So that's the tangent of theta. And then you can do the other ones. So the cosecant of theta, which is r over y, so y over r, we'll take this unsimplified version here, so it becomes negative the square root of 10 over 1 instead of 1 over the square root of 10. So it's negative the square root of 10. The secant of theta is x divided by r, so we take that and we flip them around, take the reciprocal to get that. And finally the cotangent of theta is x divided by y. So we just take the reciprocal of that, which is 1/3. So those are the six trig functions. Okay, the next one says find the reference angle and sketch theta and theta prime in standard position. So it's probably easier just to plot it and then find the reference angle. So here we have 180 degrees, 270, here we've got 241. So we know it's between these two. And if you go halfway, that would be 180 plus 45, which would be 225. So it's a little beyond that. So that's the ray. And again, we don't have to be exact about it. We just want to have a general idea of what's going on. And then you take this arc around from the positive x-axis. So that's theta. Now, theta prime is the angle between the nearest x-axis. So this is the positive x-axis. That's the negative x-axis. So this is the nearest x-axis. So if anything's in the third or second or third quadrant, you're going to measure the angle between the negative x-axis and the terminal side of the angle here. If you were in the first and fourth quadrant, then the reference angle would be with respect to the positive x-axis. And what is this angle? If I go, you can see that theta is made up of two parts. It's made up of this angle and then plus this little bit. So this is what we call the reference angle, theta prime. And the red here is just 180 degrees. So this plus that, you see graphically that 180 plus theta prime equals theta, or theta prime is theta minus 180. So the reference angle is going to be 241 minus 180, which is 61 degrees. That's this angle here. Now we'll see later where that the if I look at the sine, cosine, and tangent of 61 degrees, which is in the first quadrant, they have the same cosine, sine, and tangent as 241, except in the first quadrant they're all going to be positive. In the third quadrant, sine and cosine are negative, but the tangent's positive. So let's do another one here. 11 pi over 6. So I'm labeling the axis in radians instead of 90, 180, 270, 360, I go 0, pi over 2, pi, 3 pi over 2, 2 pi. So the question is, where does this fit? I mean, one way of doing it, if you have a hard time with fractions, would just be to do the decimal equivalent. And so I'm looking for a calculator here. And hopefully you can do it by looking at the actual fractions. But if you struggle with fractions, this on pause while I get my calculator. Okay, I'm back. So, pi is 3.14. So, 2 pi is 6.28 approximately. And if you take 3.14 times that 1.5, you'll get 4.71, and if you take 3.14 divided by 2, you get 1.57. So if you take 11 times pi divided by 6, this is equal to 5.76. Okay, so you see 5.76 is between 4.7 and 6.2, so you just need to stick into the fourth quadrant. That's the key thing here. You just need to know what quadrant it's in. So again, this is the angle, theta. The angle between that terminal side and the closest x-axis is theta prime. So if we look at what's happening here, theta plus theta prime is equal to, in this case, 2 pi. So this thing, adding these two angles gives me full circle. So you get theta prime equals 2 pi minus theta. So we can figure out what the reference angle is. It's 2 pi minus 11 pi over 6, or 11/6 pi. And then you need to convert this into sixths. So 2 times 6 is 12, so you get 12 pi over 6, same as 2 pi, minus 11 pi over 6, which is 1 pi over 6, which is just pi over 6. So this theta prime is pi over 6. And again, the significance, the reference angle, is the trig functions are the same between these two angles, except the signs are different. So, for example, if I did the sine of pi over 6, which is a reference angle, that's equal to a half. If you do the sine of 11 pi over 6, well, because the y-coordinate is the sine, you can see in the fourth quadrant y is negative, in the first quadrant it's positive, so this is going to be negative 1/2. So you can use the reference angle to get the magnitude, and you can use the quadrant information to get the sine. Okay, well, we've got one more here. So it's a negative angle. What that means is you go clockwise instead of counterclockwise. So you start off with the positive x-axis, and then you go 90, 180, 210. So 210 is going to be in the second quadrant. So you've got that. So that's negative 180, and then you're going to have this additional amount. So this is theta prime here is the reference angle. Now it's a little trickier here because trying to figure out what it is. Maybe you can think negative 180. You got another negative 30 to get here, but the reference angle is always positive. So in this case, theta prime is positive 30 degrees. You can also think of it as negative 220 is the same as going the other direction. You get to the same point. So you would, if this is 210, negative 210, that's going to be, if I have 210 plus something gives me 360, which would be 150, I think. This is 150 degrees to get the same point. So 150 plus 30 gives you 180. So you just have to think about what's going on here. The reference angles are always between 0 and 90. So if you ever get a reference angle different than that, if it's not positive, it's not the reference angle. If it's greater than 90 or less than 0, it's not going to work out. So anyway, this is theta would be this angle, theta, and it's negative because you're going clockwise around this circle. And actually, this problem wasn't related to reference angle. I have to go back and look at the sheet. This is more like problems 11 through 13. It's still true. Everything I said is true, but it says evaluate sine, cosine, and tangent without using a calculator. So how would you do that? Well, you could use the unit circle and find out where that is on the unit circle. So if you look at the unit circle, and this angle. So for the same reason, if you go negative 180, you go another 30 degrees, you're at this point right here. If you in the third quadrant, you've got these three lines, so it's this one. And if you look at the coordinates of that particular point, the coordinates on the unit circle are going to be, x is going to be negative the square root of 3 over 2, and the y coordinate is 1/2. So once you figured out where this angle corresponds to the unit circle, you can just then find the coordinates. So what that means is the cosine of theta, which is the cosine of negative 210 degrees, is equal to negative the square root of 3 over 2, and the sine of theta is positive 1/2. And then to find the tangent of theta, you can take the sine over the cosine. So the sine is 1/2 divided by the cosine, which is negative the square root of 3 over 2. You convert this division problem into a multiplication problem by taking the reciprocal off the denominator. These two cancel out, so you end up with negative 1 over the square root of 3, which then you can rationalize by multiplying and dividing by the square root of 3. And you see the tangent is negative. So here we are in Q2, second quadrant. All students take calculus. So in the second quadrant, the cosine and the tangent are negative. These are negative. The sine's positive. You can see everything agrees here. Sine's positive, cosine's negative, tangent's negative. Okay, let's do one more here. Now this angle, 21/3, if you take 21 divided by 3 on your calculator, 21 divided by 3 is 7. Well, 7 is greater than 2, or 7 pi is greater than 2 pi. So that means I have to figure out what is the equivalent or a coterminal angle in the first between 0 and 2 pi. So all you have to do is just, well, in this case you could simplify it first, 7 pi. But if you couldn't simplify it, then you would just leave this fraction. And what you do is you subtract 2 pi out. So if I subtract 2 pi, I get 5 pi. If I subtract 2 pi again, I'll get 3 pi. Subtract 2 pi again, I get pi. So you finally get a number that's between 0 and 2 pi. Now this is on the axis. If you draw a unit circle, pi is here. So as far as the unit circle here, it's -1 comma 0. X is -1, y is 0. So the cosine of pi, which is the same as the cosine of 7 pi, is -1. The sine of pi, which is the same as the sine of 7 pi, is equal to 0. And the tangent of pi, which is the same as the tangent of 7 pi, is equal to 0. How did I know that? Because tangent is sine over cosine. And let's say I had 22 pi over 3. Okay, I don't know why I chose 21. So in this case, you can't simplify. So what you would do is you would subtract not 2. You subtract 2 pi, but you put it in terms of thirds. So 2 pi is equal to 6 pi over 3. So you multiply both the numerator and the denominator by 3. So what we're going to do is we're going to subtract 6 from the numerator and keep the denominator the same. So if you subtract 2 pi or 6 pi over 3, you'll end up with 22 minus 6 is 16. So you get 16 pi over 3. That's still greater than 6 pi over 3. So then you'll subtract again, you get 10 pi over 3. 16 minus 6 is 10. Then you'll subtract 6 again, and you get 4 pi over 3. And that's finally what you need to look up on your unit circle. Now let's think about it. What is 4 pi? You can just look it up on unit circle, but let's think about the thought process if you didn't have it memorized or you didn't have it available. 4 pi over 3 is greater than pi. 4/3 is greater than pi. If you go, the next mark on there would be, this would be 6 pi over 6. Add 1 6, you get 7 pi over 6. So that's the next one. Then you have the one that's in the middle, and then you have the one that's on the third. So that one's going to be 8 pi over 6, or 4 pi over 3. So that's this point on the unit circle. And if you kind of sketch in where the x and y values are, you can see x is negative. It's about halfway between there. So the cosine of 4 pi over 3, which is also equal to the cosine of 22 pi over 3, is going to be -1/2. And the sine of 4 pi over 3, which is the same as the sine of 22 pi over 3, is equal to negative the square root of 3 over 2. And finally, the tangent of 4 pi over 3, which you can get off the unit circle, is the tangent of 22 pi over 3, which is going to be equal to the sine divided by the cosine. So you see that the negatives cancel out, the 2's cancel out, you just end up with the square root of 3. So that's the tangent. So the key thing here is that if you have a number that is greater than 2 pi, you subtract 2 pi, or the equivalent, until you get a number that is between 0 and 2 pi. And then you can then just use the unit circle to find the coordinates for this angle. And the coordinates give you x is cosine, y is sine, tangent is sine over cosine. And the last one I'm going to give you help with is, I want you to be able to do, is it says find two solutions of the given equation. Give your answer in degrees and radians. Do not use a calculator. So this is again using the unit circle. Again, I'm going to do it, kind of sketch it, but you can look at those sheets. So here's the sine of theta is square root of 3 over 2. So y equals the square root of 3 over 2. The sine is equal to y. So here's a half. Here's something greater than a half. So if I draw this a horizontal line, I'm going to get two situations. These two. And then you can just read that off. This is going to be pi over 3, and this one is 2 pi over 3. So just confirm that. So the two solutions between 0 and 2 pi, where the sine of theta is square root of 3 over 2, is pi over 3 and 2 pi over 3. Now when you have tangent, it's a little more difficult. You can figure out what quadrant they're in. And the quadrant is quadrant 2 and quadrant 4. All students take calculus. So in the second and fourth quadrant, the tangent is negative. And you can think back to actually the first quadrant. If you have the sine, the cosine, and the tangent, and the angles, which are, oh, and I forgot to do, so that's in radians, that's going to be 60 degrees, that's going to be 120 degrees. Okay, so those are the equivalent things. And you just read that off your graph that has the angles. Remember 0, let's use radians, pi over 6, pi over 2, 4, pi over 3, pi over 2. So remember the sine goes 0, a half, square root of 2 over 2, square root of 3 over 2, 1. So that's the sequence. 0 over square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Then the sine goes the opposite way. So instead of going from 0 to 1, it goes from 1 to 0. And then the tangent is sine over cosine. So you get 0 over 1. Here we ended up getting the square root of 3 over 3, 1, square root of 3, undefined. Okay, so square root of 3. That's this one. So if you wanted to find the solutions in the fourth and the second quadrants, one way of doing it would be to use this reference angle concept. So in the first quadrant, pi over 3 is like this. Well, the mirror image of that is this one right there. So if you remember, there's this unit circle, and the other, this is pi over 3. That's pi over 3. We had pi over 4, and we had pi over 6. Okay, so it's this one. So the one that's corresponding to this one, it's the one that's furthest around in this quadrant, which ends up being, if you look on your unit circle, it's going to be equal to 5 pi over 6. So that's this point, and then you have these other two like that. These correspond to each other. These correspond, and then those correspond. Likewise, in the second quadrant, the one that's symmetric with this is the one that goes here, and that ends up being 2 pi over 3. You can just read it off your graph. So the answer to your the solutions are theta equals 2 pi over 3 or 5 pi over 6. That's in terms of radians. And if you look on your chart, the corresponding angles are 120 degrees here. This one says 120, and this one is going to be equal to 300 degrees. Another way to check this is you could take 2 pi over 3 and multiply by 180 and divide by pi. That's the conversion from radians to degrees. You see that these cancel out, so you just end up with 2 times 180 divided by 3. The answer is 120. So that's that. And if you have 5 pi over 6 times 180 divided by pi, the pi's cancel out. So we take 5 times 180 divided by 6. I made a mistake, didn't I? It's good to check these things. What I should have done is, here you have 2 pi. 2 pi is, in terms of thirds, is 6 pi over 3. So 6 thirds is 2. And if I subtract it, it's 5 pi over 3. I don't know why I wrote 6 there. That was my mistake. So that's 3. 5 pi over 3. So you can replace that. So if you take 5 times 180 divided by 3, I may have said it, but I didn't do it. So 5 times 180 divided by 3 is 300. So you can get these conversions by using this multiplication, or you can just look at the angles and radians and just pull them straight off from the unit circle.